Okay, so in this picture, again, I'm going to start with a very ambiguous, I don't know what you look like case. So fill in what I know, 23, 46. This is 127. Okay, so I need angle C, angle B, and side B. So I'm going to use law of sines to find angle C first. So sine of 127 over 23 equals sine of C over 46. Alright, so I'm going to go to my calculator again. 46 times the sine of 127. Divide that by 23. And I get 1.59 equals sine of C. Now, I've paid attention to class, and I've known when Mr. Slay's trying to trick me, so there's no way that that's going to work. Now, if you want to type in your calculator and get the error, you're more than welcome to do that. So there is no triangle that has this set of numbers. So in other words, even though I gave you three numbers, those three numbers, the way that they're set up, will never form an actual triangle. Alright, and lastly, in this set, is this little part right here, and I realized I've got a typo. I meant for that to say, uh-oh, I'm going to be shot for this. I meant for those all to be sides, instead of, looks like an angle there. Is that consistent with the numbers at least? Okay, so yep, it is a little ambiguous, so I apologize for that. So that's supposed to be 3, that's supposed to be 4, and that's supposed to be 6. Okay, so what I want to do is I want to use law of cosines this time, and I want to start with angle C. So law of cosines says 6 squared equals 3 squared plus 4 squared minus 2 times 3 times 4 cosine of C. And then I just want to go to my calculator, and I'm actually going to go subtract first. So 6 squared minus 3 squared minus 4 squared should get 11. And I want to divide that by the negative 2 times 3 times 4. And I get negative 0.458 is equal to the cosine of angle C. So then I want to arc cosine that. And I get that C is 117.28. So 117.28. Okay, now the nice part is, now that I got the biggest angle in the triangle, I can now kick in law of sines without worry of ambiguous case showing up. And I'll just, let's see, sine of A over 3, and we'll set up a sine of B. Actually, no, I'm just going to subtract from 180. Why would I do that? Okay. All right, so let's cross multiply here. So sine of that angle of the 117 times 3 divided by 6. Okay, and then I want to arc sine that. And you should get that A is equal to 26.38. I should probably keep track of this. I needed angle, yeah, why not? I need angle A, angle B, and angle C. Okay, and we said angle C was 117.25 degrees. Angle A is 26.38 degrees. And then I'm just going to do the 180 thing. So 26.38 minus 117.25. And I get that angle B is 36.37 degrees. Number 25 and 26, I wanted to clarify that those are non-calculator questions, so you won't be near a calculator when you are working these. So I want to start by thinking of unit circle values that add up to or subtract to 105. So I'm just going to make a list. We got 30, 60, 90, 45, and I need any of that set to make this 105. And I can see that 60 and 45 work. So sine of 60 plus 45 will give me 105. So the sum of sine formula is sine of 60 times sine of 45 plus, cosine of 45. Although on that case it doesn't matter, but anyways, cosine of 45. Okay, so then that's cosine 60 times sine of 45. And so then I am just writing down the sine and cosines of 60. So for 60, it's 1/2 times the square root of 2 over 2 plus square root of 3 over 2 times 1 square root of 2 over 2. And so if I multiply across, I get square root of 2 plus the square root of 6 all over 4. All right. Now, number 26. Let's see, negative 11 pi 12ths. So let me start by making a list of our common ones. So pi halves, pi thirds, pi fourths, pi sixths. And let me rewrite them in terms of twelfths, and maybe we can see a little bit better where negative 11 pi 12ths would come up. So this would be 6 pi 12ths, 4 pi 12ths, 3 pi 12ths, and 2 pi 12ths. Okay, do we see a combination of 11? Let's see, I can see 10, I can see 7, okay. Well, then I'm going to have to go to another quadrant. I'm going to have to bring up second quadrant angles and include those in my list. So in the second quadrant we have, we've got 3 pi fourths, we have 2 pi thirds, 5 pi sixths. Pi halves doesn't have a second quadrant form, but if I convert that into their pi 12th forms, let's see, let's multiply by 4 on that one, so 8 pi 12ths. This would be times 9 pi 12ths, and then this would be 10 pi 12ths. Okay, so do I see 11, a way for 11 to show up? And I can see one. If I take 3 pi fourths and 9 pi 12, no, that's 12 pi 12ths. Okay, that was close. Let's see, what else would I got? Oh, 2 pi 12ths. Okay, how about that? How about I take, all right, so we'll do this. We'll do negative 9 pi 12ths minus 2 pi 12ths. And that'll give me negative 11 pi 12ths. Okay, now again, there's other ways to do that, but that's the one that I saw, so that's what I'm going with. So originally, that would be the tangent of 3 pi fourths, negative 3 pi fourths, subtract pi 6. Okay, so now I got to use the difference of tangent formula. Or I could just use sum of tangent, just make everybody negative. Let's do that. Let's just do sum of negatives. Why not? Might as well stick to something easy. So tangent of negative 3 pi fourths plus tangent of negative pi 6 all over 1 minus tangent of 3 pi fourths times tangent, negative 3 pi fourths and tangent of negative pi 6. Okay. All right, so now this just goes back to how well we know our unit circle. So negative 3 pi fourths, well, tangent of 3 pi fourths, let's see, that's actually tangent of pi fourths is 1. So we're in negative 3 pi fourths puts us in the third. So this actually is 1 plus, and then pi 6, tangent of pi 6 is square root of 3 over 3, but a negative puts it in the fourth quadrant. So negative square root of 3 over 3. So 1 minus, all right, so we just said that it is 1, and we just said that that was negative square root of 3 over 3. Okay, so now we just got to simplify this and make it somewhat prettier form. So 1 minus the square root 3 over 3. And down below we actually get 1 plus the square root 3 over 3. I'm going to multiply everybody. I'm going to multiply by 3 over 3. That'll at least get rid of the fractions. Let's actually multiply that as opposed to what I just wrote. So I get 3 minus the square root of 3 and 3 plus the square root of 3. And that's mostly a good answer, but we know about conjugates. So I'll multiply by the conjugate. So up top, let's see, down below, that's probably the easier one. I get 3 squared minus the square root of 3 squared, which is 9 minus 3, so that's just something over 6. Okay, and up top, let's see. I get, I'm okay, let's just leave it like that. Square root of 3 squared. So we'll just kind of carry that all the way over here. Okay, so 3 minus the square root of 3 squared. Okay, and I think that's a more correct answer. But you know what, I'm going to come back here. And I'm going to also box in this. I think students that get that far, I think, deserve a passing grade. Honestly, I think the student that actually remembers their conjugates deserves a higher grade, but you survived the tangent, so good job. All right, so in number 27, we're asked to find the sine of 2x, given that the cosine of x is 4/5. This, oddly, is a non-calculator skill, so we're not being asked to type it in the calculator at all. But we are asked to sort of think back to the identity. So the double angle of sine is 2 sine x cosine x, of which I have cosine x. So if I knew sine x, that'd be good. Well, let's take a second and translate what on earth all this means. So if I have a positive cosine, cosine is positive in the first and also in the fourth. Okay. Now cosecant is negative. Well, where would cosecant be negative? Well, especially out of those two options. Given that we're either first or fourth, well, in the first everybody's positive. So we have to be looking at the fourth quadrant with this. So what I'm going to do is I'm going to set up a reference triangle. And I'm going to label cosine. So here's my theta. Cosine is adjacent over hypotenuse. So this would be 5 squared minus 4 squared, which oddly enough is 3. So I need sine out of this. So sine x is 3/5. Okay, so 2 times 3/5 times 4/5. And actually, let's rethink this. That should be a -3, shouldn't it? Because they're in the fourth. Okay, so that would be over 25. It's negative. 2 times 3 is 6, and 6 times 4 is 24, so negative 24, 25. Negative 24 25ths. Number 28, use the appropriate half-angle formula to find the sine of 15. Okay, well, the only half-angle formula we happen to know, so sine of 15 degrees, is the square root of 1 minus cosine of 2 times 15 all over 2. So 1 minus cosine of 30 over 2. All right, cosine of 30 is square root 3 over 2. All right, so we got a lot of over 2's here. Let's put, say, come here you, oops, too far. Okay, so let's rewrite that 1 as 2 over 2 minus the square root 3 over 2 over minus the square root of 3 over 2. Sorry, I'm getting ahead of myself. Over 2, still over 2. All right, so that's 2 minus the square root of 3 over 2 over 2. And so that's 2 minus the square root of 3 over 4. And the 4 can simplify to get out of the radical. So we end up with 2 minus the square root of 3, all of which is over 2. And so that's our final answer.